Alright, back for another video, still in Brown's Chemistry, the Central Science, Chapter 1, learning the basics here, understanding matter and measurement. So we have a go figure style problem. The prompt: what is the connection between the relative gas volumes collected in two tubes and the relative number of gas molecules in the tubes? And so the example, to illustrate this problem, we have water depicted here on the left. Lots of water molecules in the liquid state, H2O. The reaction here is the electrolysis of water. So to read you the description, water decomposes into its component elements, hydrogen and oxygen, when an electrical current is passed through it. The volume of hydrogen collected in the right test tube is twice the volume of oxygen. So again, revisiting the prompt, what's the connection between our relative, that's the important word in this question, gas volumes collected in the two tubes, and again, the relative number of gas molecules in the tubes. If you've maybe had high school chemistry or an introductory physics course, you might be thinking PV equals nRT, and that does have relevance here. However, at this point in the text, we've not been introduced to the ideal gas equation, so we're not going to factor it into this discussion, but simply we say the relative volumes are the same because the amount of hydrogen is twice the amount of oxygen. And that relates back to the molecular structure of water. For every one oxygen molecule, there are two hydrogen molecules. So during the electrolysis of water, for every one oxygen molecule that is formed, we're forming two molecules of hydrogen. Again, remember that an atom of oxygen is just a single red ball, but the molecule of oxygen would be the two red balls stuck together. Same goes for the hydrogen. So, and you can sort of visually tell the roundness of the test tube bottom probably makes it look a bit deceiving, but the volumes look about, if you look at this volume here on the left, get my pen, which is the volume of oxygen, it looks to be about half the volume contained in the hydrogen test tube. So visually, you can sort of make that determination. And the formal answer given in the text, similar to the figure caption, the relative volumes are the same. There are twice as many hydrogen molecules as oxygen molecules, and thus the hydrogen gas takes up twice the volume of the oxygen gas. So an interesting connection between the number of molecules and the amount of space or volume that they occupy, which just in our day-to-day life sort of makes more sense. Clutter, the more things you have, the more space it's going to take up. This comes back to laws of proportions, conservation of mass, etc. But to simply describe the problem, more molecules, more volume.